Hello everybody, this is Li Yunyue. I'm working with Basan for this assignment too. Now, I'm not gonna to introduce a new feature, a new feature about our method calling KMEs. This is the method using for k-means clustering. And the number of centers that we designed is 4, because according to the learning set, we find out that they will correspond to have 4 groups with different points. And now we are adding a new feature. The new feature is like we are going to print out for each cluster or for each group what are the points included or what are the situation included for each class or for each group or cluster. So now let's run it to see the result. Okay, here you see this is the input, this is the output. The printout screen is here. So basically we have 4 class. This is class 0 with the class center. This is one position of the 18 given position, just to check what is the real point of the cluster center. And the size of the first class is 49. So that means among the 200 learning points in the learning site, we have 49 points included in the class 0. And you can see here for class 0, I have printed out the point included with the given value. Let's say this is the first point with the voltage level in per unit system and the angle of this bus bar, and also for the other bus bar. For example, for this one wing, we have the voltage level of 1 per unit and the angle of this bus bar. So the first line, every line corresponding to 1 point. So you can see I print out the point included for, let's say this is the first point in the class 0. So the exact or the detail is given by here. So and then we can check that we have 9 points included in total. So it's like from here until here. And in order to classify which situation we have corresponding to the first to the 0 class that we have, we need to take a deep look of the data detail. For example, for the class 0, let's say we have the angle of the generation bar is minus, and for another generation bar wing is also minus. At this point, we consider that this class 0 corresponding to the case given in the low load rate during night. So it's like this. Because we are thinking like, because the angle is minus, so which means like the reactive power of this bus bar is minus because the sinusoidal of function of this angle is minus. So which means like our generator receive the reactive power from the power system or let's say from the grid. So that means we don't need so much reactive power to compensate in our system. So that means we have less load, or we have less inductive load. So we have low load during the night corresponding to class 0. And now let's take a look of the class 1. So that's the second group. In this group, we have 51 points included. And for this group, we can find out let's say the angle of the generation bar is positive. Another one is also positive. And also for other bus bar, we can also take a look. It's also positive. So let's say our generation bar providing the reactive power to the 6th grid system. Under this condition, we think that class 1 corresponding to the case of high load rate during peak hours. Okay, let's take a look of the third one, which calls class 2. In this group, we have 53 points. And take a look of the data, we will find out, let's see the angle of the generation bar. Now, one of the 8 is positive, another one is minus. So which means like we have for one generation bar like M, this one, we receive the reactive power from the grid, and for another one we need to for this one we provide the reactive power for the grid, and for this one we receive the reactive power from the grid. So we can conclude that the class 2 corresponding to the case of shutdown of one generator for maintenance. And now let's take a look of the last group, which have 47 points included. And this is called class 3. And in order to know which type of situation is corresponding to class 3, we need to take a look of the detail again. And in this case, we can find out that for both of the generation bar, the angle is positive. Well, we find out that for some of the bar, the angle is negative. Some of them exist. So compared to the previous case, we can conclude that the last group corresponding to a case of disconnection of a line for maintenance. So this is basically what I have done to adding one feature. It's like to print out for different group the detail of the group and to explain which situation corresponding to each group. And now let's take another things that need to consider, need to explain is like for KAN method. Let's say how could we determine the way that the number of k in KAN means. That means how could we decide how many points we need to collect that are among that are the nearest that are the k nearest point of the point that we are going to study. So here I have pointed out to 14. The reason is like I'm reading from the website, and they said that it's more accurate in most cases that we have the k, which corresponding to the square root of the given learning set point number. So here we have 200 learning set point, and the square root of 200 is approximately 14. So this is why I'm giving the key value is 14 for the KN method. Okay, so this is basically what I have done to improve our code and our printout, and also to explain how to determine the k value for KN method. So thank you very much.